Pilkington Plateau ve Pilkington Planner Uluslararası Satış Yöneticisi Chris Barlow'u Pilkington Yapısal Cam Sistemleri başlıklı sunumunu paylaşması üzerine sahneye davet ediyorum. Teşekkürler.
Yeah. Hi. I'll try not to take too much of your time since basically we're going to talk about Pilkington Plano as the mainstay. Pilkington Plateau that they initially sort of highlighted as one of the products is a product that's specifically for acrylic casting and probably really not for this audience. So I'm just really going to remind you what Pilkington Plano is all about. If you're searching for it on the Pilkington website, it's under the Glass Systems logo. You'll go under there and you'll find Pilkington Planar, and you'll also find Profilit down there. So what is Planar? It's the world's leading structural glass system. We've been doing it for over 40 years. We developed this system in the late 80s, and we are continually developing it as we go on year after year. We design and supply it worldwide through a network of accredited installers, and we do in-house testing. The one thing that we do sort of live and work by is the 12-year design and manufacturer warranty. So every design that we manufacture, I will sign off, one of the in-house engineers will sign off, and we will be responsible for that design and all the materials we supply to site. So what are the essential benefits of Pilkington Planar? As I said before, we continually test. I will show you some tests that we continually do to ensure that the product quality and the code of practice that we work to is robust, and we can guarantee that what we're actually designing for you will stand up and will be there for 20-25 years. So we have a code of practice that we've developed over the last 40 years. Every year we test in excess of 200 glasses to destruction in the factory, and what we do is we record all that data and we use that to input back into how we design. I've mentioned before we have the 12-year warranty. We usually work through a network of accredited installers, and that basically gives you the peace of mind and the quality that you're going to get a good product. We have a team of in-house engineers. I'm one of the in-house design engineers. Sadly, I also do the sales as well, so I must have been a bad boy somewhere along the way. One thing that helps us with the Pilkington Planar thing is the reputation. We've got our heritage as Pilkington. Pilkington started in 1826, and the brand is basically what you are actually buying as a product. We have one dedicated factory throughout the world, which is in St Helens, just between Liverpool and Manchester in northwest England. And all we do is we manufacture Pilkington Planar, and that's thick glass compared to any other processes within the country. We have a large product suite that we can use. We can use almost every product that Pilkington manufacture, so we can give you a supply product that will actually meet the current demands. As I said before, worldwide installations anywhere from South America, North America, Europe, Asia, New Zealand, you name it, generally we've been there, we've seen it, and we've got the air miles. So we have an ability to offer site technical assistance, so our engineers can actually come out on site and oversee any help that you need if it's a difficult installation. We're quality assurance registered, so we've got 9001, 14001, kite marks for the UK, etc. And the one thing that stands us apart is we supply the bolts, the glass, the fittings, the design. It's a single source supply, so if there's any problems, you come to Pilkington and we will solve it for you. So quality is the one thing that we actually sell Pilkington Planar on. The quality of the glass, the quality of the toughening. I'm not sure if people understand how difficult it is to get thick glass very, very flat. I don't want to steal Steve's thunder where he was anti-reflective, but in Pilkington Planar we like quite reflective glasses because that shows how good the quality of the product is. So On here you will see there's two glasses. This is a toughened glass that we bought from our competitors. This is a standard 6mm toughened to 0.02, which is the standard roller wave. This is a Pilkington planar version. This is the one we make in our factory. So you'll see, just by looking at the reflectance that you've got there, you've got the roller wave where the glass has taken the shape of the rollers when it's become a molten state when you've tempered it. Just to show you how good that 0.02 reflection is, that is a fully toughened double glazed unit in a facade, and you'll see this is the reflection of the building on the other side of the road, and you can actually see through it. So we like reflectance because it shows how good the product is. We can go and show you how other products deal with the same thing. This is an alternative product that is classed as a Pilkington planar equal or approved, and you can see the reflectance in there is not anywhere near as good as ours. And this one is a very good one. You can see here the struts and the columns in the building there. When they've toughened the glass, they completely lose it. So the idea is what we're trying to do is give you an inside-out reflectance feeling that it's part of an architectural product. Again, just one aspect when you're doing double glazed, and we look at thin outer glasses where we clamp a thick inner glass. When you get temperature changes, the glass will move inherently because the air gap that you've got is sealed. So when that gas expands, one of the glasses has to move. When you use the fixing where you have the thinner glass on the outside, you get what you class as the pillowing effect. So the outer glass is the one that moves. The Pilkington planar has the same issue. All we do is the thinner glass is on the inside, so you don't see that effect when it happens. Engineering, part of our business is we have in-house engineers, so we can extend. We're constantly redefining what we can, what we can't do, and we're working with seismic zones. We've got jobs in the USA where we've actually built structural glass across fault zones. We've got hurricane resistant glass, which is for down the east coast of America. We've got blast mitigation, which I'll show you a couple of videos later. But what we're trying to do is we're trying to make sure that you can use the glass qualities that Pilkington are developing with the coatings, etc., so you can open the building out but still have a structural facade there. Generally, our glass configurations are as you would expect from any manufacturer. We can go from monolithic, 10 up to 19mm toughened. We can do laminates where we have the thick glass on the outer of the laminate. We can have the thick glass on the inner of the laminate, depending on what the requirements are. Standard double glazed units, we can actually do heavy duty double glazed units where we can have a 10, 15mm outer and a 15mm inner if required. We can laminate them, we can triple glaze them now to get the U values down to 1, 0.75, and we can even triple glaze laminate now. So the applications are very, very varied. I will just go through a quick shot of what the fittings are, and I'll show you a load of pictures because that says a lot more than what I can actually tell you. So, standard range of fittings that we work to, 902s, basically we have a 902, these type here, that is just a little disc that fixes back to an angle plate. We have the 905, which is the mainstay. When we do mullions, we splice them with a stainless steel, and we have the obvious spider casting as well in the range. One thing that does stand us out differently from most other structural glass systems is we've been developing this for 40 years. We're quite comfortable to do single toughened glass fins, 20, 25. We've got a 28 meter tall toughened glass fin there. We don't need to laminate it because the way it's actually designed, we know that if that glass fails in that fin, the facade is not going to collapse because we've designed it in accordance to share those loads throughout the building. So I'll just go through what you can do as architects and people who are looking at buildings. These are just gives you ideas of what you can do, and we'll show you later that if you can think about it and draw it, you can generally have it. So we've got single glazed. This is a 10mm body tinted glass on a tension structure. We've got a single glazed double skim wall in a power station. We can get single glazed laminates. These are the two laminates. This one here is where we've got the thinner glass on the outer, and this is the thinner glass on the inner. Sentry Glass Plus, we use that in areas of high load capacity. So this in Canada, there are certain areas in here that we had snow loads of over 4.2 kilopascals. So we had to use the Sentry Glass Plus to allow us to load share. It didn't thicken the unit up considerably, a couple of millimeters, but it allowed us to go from 2 to 4 kilopascals as a load capacity. We can do opti-white, so we can get as much light into the building, make it as clear as we possibly can. A couple of jobs here that we've done, double glazed opti-white. We can do triple glazed. This is a triple glazed to a fin, so it's basically they're trying to make the inside come to the outside. We can do triple glazed where it's to fins and we've split the fins. We've got glass mullions. They don't have to be vertical. Everybody thinks they have to be vertical. This is on a faceted facade, and the fins are actually leaning back. So, as I said before, a lot of it that we like to sell, and part of the product to show the quality, is the reflectance. So all these pictures show you the reflectance and how good the quality of the glass is. These type of, when you're using fins like this, it gives you the opportunity to use the horizontality of the whole product. You've got all the glass, you've got the repetition, you can use the form of that glass within those areas to try and make it an outstanding area. So this is what the architects have actually done on these glass fin areas. We can easily put the fins on the outside, so you can have more space on the inside. We can colour the fins if we laminate them, so you can make them an actual feature on the project. And then we go back to the standard pieces of steelwork, fixing glass to. The one difference between this and any other steelwork is that it's actually a bomb blast entrance, but you wouldn't know because of the way it's been designed. We can colour it into layers. Standard steel outriggers, so it's just a standard steel form, and what we tried to do is, because of the quality of the glass and the reflection and the size of the panels we can use use a bigger glass area with the coatings to make it a more comfortable environment. We can do tension structures. This is a big tension structure in New York. Sorry for I stretched it, it should be a bit more. But that was 60 meters tall, and just to show you how big it is, there's a guy there. That's to show you how tall that is as a facade. So we just have more tension structures, very, very fine, very sleek, stainless steel, mild steel painted. You can have what you want. We can do cable nets when we get to them that remove even part of the tension structure, so you've got more space within the building. These buildings with cable nets will move considerably, anything up to 300-400 millimeters, but if they're designed in accordance with the wind loads and the movements, you're not going to have any structural failure. We can do skylights. We can do a combination of skylights with tension structure and fins. It's an open book to you. You can do exactly what you want. Canopies, overslung, underslung, one piece, two pieces. You can do it in different planes. It's purely, if we can design it and we can draw it, basically you can have that as a final project. hybrid structures which don't fit into any category. We do these on specific projects where there's the time allowed for the design and for the testing. So at AOL we've got horizontal glass fins with a vertical semi sort of cable net structure, and there's still some steelwork in there. Dual skins, so we get the ability of working with the single reflective glasses that we can get from North America, and on the internal we can have standard unit, double glazed units that we can keep the heat in the building, and the outer glass will stop the heat actually trying to get in. So we can do that, and again, the product that we sell and the way that we toughen thick glass gives you an instant architectural facade that is worth looking at. We can do Pilkington Active, so we can do the self-cleaning glass as well, so if there's areas that are inaccessible, we can actually do that as a part of the structural glass as well. But this is where we come to the point as architects and designers. If you can design it and put it onto a piece of paper, generally we can take that concept and through redesign of fittings or things that we have to do within the factory, we can actually give you what you require. So that's a job in Azerbaijan where we had to redesign the fittings, we had to have project-specific castings because of the geometry, but the architect got the concept that they wanted for the project. So very briefly, solar control, we can use all the glasses within the range. Thermal insulation, we can double glaze it. At the moment we can't do fire protection, that's the only limitation to Pilkington Planar. We can do self-cleaning and we can do PV cells. I'll show you a couple of things on engineering and testing just so you can understand where we come from and what we actually put in. It's not just a piece of glass from a toughening furnace. So when we do testing, we can do testing in-house or we do independent test laboratories. So these are full-scale project tests that we will have done. These are the blast mitigation tests that we will have done. We do impact resistance in the factory. We do that as part of the Pilkington general scope. This is a video of a double glazed unit that we're actually just putting wind pressure to. It's a 10mm inner, 6mm outer, and there's 4 fittings on each glass, 1 in each corner. So you'll see as we load it and unload it, you'll see the deflection on the edges here. This will turn as it takes the glass out. This just shows you how flexible, when you fully toughen it to a higher level, what you can actually do with a piece of toughened glass. There's nothing special about that. All we've done is just toughen it to a level that's suitable for us to be structural. Just to show you what the fittings do, this is the central part of the glass, just so you can get an idea of how far the whole thing actually flexes and the differential vision that you're going to get. But when you actually load, you've got to work with the fittings because you overstress the glass. Now you'll see these fittings move around considerably as we're loading and cycling this glass, and this is what the glasses will go through in a lifetime. So we will design these glasses to be independent, to make sure that they go through this process. And the one thing we've got to do is, as they go through that process, is they don't break. So we constantly design to this degree to make sure that what we're actually putting on the market and giving you a warranty that's backed for 12 years is where we can sleep soundly at night that this will work for you. We couldn't actually fail this because the deflection on the unit was too high. So we can do photovoltaic cells now. This is part of a ongoing sort of design that we're doing. This was a replacement job. It was a 12-year, well, it was probably in excess of 12 years that this job had been up, and what we got was the customer came back and said, I need to replace the glass, I need it to be modern, and I need these PV cells in it. So what we've done is we've replaced it, same fittings, slightly different glass, but we've put the PV cells in for them. So we can actually include that into the projects that we do now, so we can get some sort of green sort of rating on there. Blast mitigation, I think we showed something about this last time, but since we've done this, we've done 40 more tests. This is 100 kilograms of TNT. That is probably the biggest blast load that you will be looking at the moment. It's about 490 kilopascals per millisecond, which is the initial impact, and then we have an overpressure of about 84 kilopascals. So we've designed to that. You'll see these are the glasses that we put in. They're a double glazed laminated unit, and because it's designed specifically for what the client wanted, we can make sure that those glasses will not break. So if they put a 200 kilogram bomb in, of course they will break, but the threat level is what we need there. So we have a blast resistant glass. We can do it for anything from pocket bombs, mini bombs, and full scale bombs. All we need to do is understand what the threat level is, i.e. the impulse, the overpressure, and what classification are you working to, the American, the ISO, the European. Does the glass need to stay in place? Is it going to be a sacrificial wall? And then, depending on what we're doing, even though we say Century Glass Plus is a strong interlayer and it works well with us, it may not necessarily be the better product for a blast resistance. So we need to look at everything all together, and we will give you a solution to the requirements the customer wants. I was going to show you a video here. This is a full-scale test on many of our glasses within the range. The hurricane test, what we basically do is out of that tube we send a piece of pine wood at 10 feet per second, and basically we just ram it into the glass, and depending on the glass structure and the glass type, it will either break or it will actually survive. The ones on the left will eventually break. The ones on the right, because they're structural laminates, we will be able to impact those and then wind load them for the number of cycles that we need to do. So now we have a product that we can actually sell within the east coast of America as a hurricane impact glass. So briefly to summarize, it's designed and manufactured to the most expecting standards. We actually toughen higher than standard toughening levels. The quality that we give you is for the facade is what we sell the whole thing on. It's versatile. We can change the fittings, we can change the unit, we can change the glass types. It all depends what you want. You know, we're developing, as you see, we do a lot of engineering on ongoing development, because we need to keep that technical advantage at the forefront. The new coatings I'll briefly go on to, because I'm not sure whether you've been briefed, but the new coatings that are available from the UK, we can actually use those toughenable sun coats now. And as we say, it's the ultimate structural glass. That Coca-Cola bottle there is a 2-story lift shaft in Las Vegas. So during the night when the shop's shut, it's black, looks like a full bottle of Coke. When it's during the day and the shop's open and it's light, it's all green, it looks like an empty bottle of Coke. But if you go to Las Vegas and you're looking for that, don't be looking up, because it looks about that big in Las Vegas, because everything is twice as big. I'll briefly go onto the coated glasses that we can offer. This is the new £35 million online coating line that's been installed in the UK. Came online in November 2012. It's the most advanced coater in the NSG group, and we believe it's the most advanced coater in Europe at present. Potential to do up to triple silver coatings that we can do, for instance 6227. It's local to where we are. PA is Pilkington Architectural, apologies for that. But it's local to where we are, so we can get the glass very quickly. We can actually utilise OptiWhite as a glass as well, so we can put the coatings onto an OptiWhite. We can go up to 15 millimetre, so that gives us the ability to use these coatings on a structural glass. Pro-T are the coatings that you can post-temperable toughen, so it gives us the ability to be able to toughen those rather than just have a pure soft coat. At the moment we can't do cut sizes, but that is because the line at the moment is very, very busy. So just some of the OptiTherms. We've got the thermal range that we can do. The Suncools are the ones that people are looking at, which is a solar and a thermal, and they're the ones that we're looking to be releasing. So we'll be looking to release 70-40, 66-33, 50-25 and 70-35 at the moment. These are the ones available in the UK. The ones you'll probably be looking at are the 70-40s, 66-33s, but we're moving to the second trials of the even more enhanced ones, which are the 40-22s and the 30-15s. We'll be trialling those in the next few months for Pilkington, looking at the thick levels, and then what we will do, they will come to full commercial release probably mid-2015 to the market. So they're generally in jumbo sizes. Standard is an Opti float clear. If we want to have them on OptiWhite, we need to forecast them and we need to know in advance so we can actually design that through the process. We can do standard units that we can offer to the market. Generally these are up to 6 metre by 2.8 metre, 4 to 19 millimetres. We can use all of those coatings, as we've said before. We can use all the coatings that Pilkington North America do. Again, just some very, very simple pictures. And then just a final one, just to show you how good Pilkington glass is. We did a television programme with the BBC a couple of years back, and we used Centriglass Plus to show how strong you can actually make the glass. So this video will have two 10mm toughened pieces of glass with a 1.52mm Centriglass Plus interlayer. Unfortunately, we couldn't take the car any higher because that was the roof of the test lab, but originally the BBC wanted to drop it from 3 feet. We got to about 5-6 feet. So the glass didn't break. What we're saying there is, with DuPont's structural interlayer combined with Pilkington, looking at what we can do, we can actually make glasses that are very, very strong but don't impeach on any of the visual aspects that you're looking for. That's me. Hopefully I haven't sent you all to sleep and you need a coffee. So, any questions? No? Good.
A quick one. Most of your bolted structures, the head of the bolt goes into the chamfered hole of the glass,
into a camp,
making this flush with the face of the glass. Does it make it stronger as far as the glass is concerned, or is it the patch type better? I mean, when you're calculating the glass in one way or the other,
it depends.
Which is stronger?
You have to, if you go with the countersunk hole that we use, you're actually putting the stress into the glass, so the glass is stiffer. If you use the rotool system, which if it's in a single glass, that sometimes has a cancer-sunk hole, but because of the road tool, you have to thicken the glass up to get an equal deflection.
You use the thinner glass when your counter's sinking.
Yeah, we can use slightly thinner glass because we're actually stressing the glass rather than allowing the fittings to take all the work. So we can have smaller fittings, we only use an M8 bolt that goes through the glass, so it's very, very small. But we can, we have a system where we work on the inside, as a competitive system, but we always go back to what we've tested over the 40 years.
Thank you.
Okay? Okay, thank you.